All right, so we are moving on to domain of a quadratic function. This is target B. Oh yeah, I know you guys are excited about this. Anyway, learning goals. I can determine the interval that a graph is increasing or decreasing on. Determine the domain of a graph where the values dependent variable are greater than 0. Should be of the. Thought that sounded odd. Explain the meaning of a given path or graphical representation of a real-world problem in a mathematical context. Find the domain of a function when given an equation. And finally, identify the maximum/minimum, increasing/decreasing intervals of a graph and describe how the change affects whatever. I think that's just affects, how the change affects the graph, the problem. We'll find out. Okay. Anyway, again, as always, make sure you come back to these. Check each one. Make sure that at the end of this video you know how to do each one, and if you don't, you know that you missed something and go back and do it again, or ask me for help. All right, some refresher vocabulary since you will need it. Domain, independent or the x values of a function. Interval, a selected portion of the domain. Maximum, minimum, the highest or lowest points in a parabola. So if you have a parabola that looks like this, you have a max. If you have a parabola that looks like this, you have a minimum. All right, so this graph gives a stopping distance for an automotive on a wet roadway. What happens to the stopping distance as it compares to speed? What is happening to the stopping distance as it compares to speed? So as speed increases, the stopping distance also increases. Okay. Determine the interval where the stopping distance is increasing. Well, it's increasing everywhere from here on. Okay, we're not given a specific interval. We just want to know where it's increasing. Well, it's always increasing. So we would say that x is greater than or equal to 0, or you could say 0 is less than or equal to x. They mean the same thing. Simple enough. Second example. Determine the interval where the seller earns revenue. So with this graph, it might be a little confusing because the answer is actually pretty obvious. So what I'm going to do is I'm going to extend the graph a bit. So I'm going to go ahead and move this down. And then just imagine these are all here. We'll extend this a little bit this way. Put some imaginary lines in here. Here. Okay, so imagine that this graph continues here. Okay? So this graph is, we're just drawing here, even though, because this is a real world problem, the way that it was originally drawn is the correct way. A lot of times you'll see graphs like this. And the reason why this doesn't work is because we can't, I mean, technically we could do this part of it because we're dealing with revenue and price and whatnot. But price can't be less than 0. You can't, I mean, if it's less than 0, if it's 0, it's free. You can't pay someone to take your product. I suppose you could, but it's a bad business model. Anyway, we want to know the interval where the seller earns revenue. So that means where our revenue is positive. So that would be anything up in this area. Yep, I didn't mean to do that. Let's fix that. Okay, so I went to highlight. There we go. So that would mean anything in this area would be where my revenue, so where my graph is in positive numbers. All right, so it's earning revenue anywhere where my graph is in positive numbers. And actually what I should do is technically I should get rid of this, that underneath spot. So let me try and find a color that kind of matches the background there. There we go. And if I asked you why you think that is, hopefully at least some of you would be able to give me an answer as well. If x is equal to 0, you're not earning a revenue. Your revenue is still 0, so you're not earning a revenue, so it's got to be greater than 0. So notice how over here, okay, this symbol is greater than, but this one's greater than or equal to. Okay, because anything, and actually that one should also be, silly me, Because again, it would be on 0. So this one should not have the or equal to underneath either. It's got to be in between those two amounts. Otherwise, its revenue is 0 or less. So we just keep the symbols without. So this is an example of where you would want it to not have the or equal to symbol. It's just your X, or in this case your price, has to be more than 0 but less than 63. Okay, determine the meaning of the domain below, domain of the image below. So all you have to do is give me what you think the domain would be. So obviously we kind of get an idea that this is height here. Okay, this from here to here, this is your domain, remember? So our X values, what could that represent? Could represent a couple things. Could be either time passing that the dolphin is in the air, or it could be the horizontal distance that the dolphin travels as it leaps out of the water. Either would be an acceptable answer. Okay, I meant for this to appear a little bit later, but we'll roll with it. So, forget this is there for a second. After t seconds, the ball is tossed in the air from the ground level and reaches a height of h feet, and we are given the equation h equals negative 16t squared plus 144t. So you can put this in the graphing utility of your choice. And when you put it in, you'll notice you get this nice graph. You might have to change the window so you can see it, because notice my x values only go from 0 to 9, but look at how high my y values go. So keep that in mind. If you get a graph that just looks like kind of like a straight line, you're like, wait a minute, Mr. Higgins, my graph looks like this. It doesn't look like a parabola. Try zooming out first. All right, so remember domain, we're only looking at our x values. So from our x-intercept to our x-intercept. So our x values are 0 and 9. Okay, so our x-intercepts, which let me go ahead, they're labeled on there, but just so that you can see where I'm talking about. Let me zoom back out if I can. Come on. There we go. Whoa. All right. So our x-intercepts right here and here, and all you have to do is look at the x value at those spots. Okay? Moving right along. Within the interval, x is less than or equal to 0, but greater than or equal to 0, but less than or equal to 14. Determine the years where the function is decreasing. So from 0 to 14. So that means that everything in this area here is game. Anything beyond that we don't care about. So when is the function decreasing? So when is it going down? Well, it's going down from right here until right here, and that right is at 7. So the year, this is years since 1990. So the function is decreasing when x is greater than or equal to 0 but less than or equal to 7. So it's decreasing on that interval, and that's how we write it. It's increasing for the rest of it. So we just 7x is greater than or equal to 7, but now less than or equal to 14. Remember, even though the graph keeps going, we did say that the interval was in between 0 and 14. And in which year was the average hours per person watching television the least? All you have to do is look at this one right here. That's its lowest point. We said it was at 7. Notice it didn't say how many years since 1990. So that means we're going to have to tack 7 onto 1990, which is going to give us 1997. And that's all there is for the second target. Again, not a ton of math, really. Just a lot of interpreting and using your brain and seeing what makes sense. And it is really, really easy to make mistakes. So calm your mind down. Think about these things in a way that makes sense. Really look at the graph and say, okay, what's going on here? And you guys will be fine. That's all I have for you, but if you have anything for me, hunt me down when you see me next. Take care.